Alright. Hello all, hello world. It appears I'm actually early for the first time in a while, so that's pretty good at least. This is day 79, I think. I hope I counted correctly. I'm always paranoid that I didn't count correctly, but yeah. This is day 79 of studying compilers every day until I land a compiler role. The saga for instruction selection continues. It continues forever because it's difficult. That stuff is not easy. There's a lot of moving parts to it, and I think the whole outline for all the moving parts I want to get done total are on here on the screen. This is admittedly a very exhaustive list, so I don't intend on getting all of this done today. This was like the same list as yesterday, but this is like a rough list of the things I need to get done as a whole. Yeah, so I guess I'll get straight into it. Last time, what did we do? Oh yeah, we built out a bunch of the visitors, and or I guess we just built things out a little bit more as a whole. So this all has like a little bit of shape now, which is really nice. There's a bunch of to-dos. There's a lot of stuff about calling convention, which I need to think about still, but that is a later issue for me to worry about. The thing that I care about today will be this little to do here, which is this traverse least branches thing. I've thought about it. I think I have some ideas on how I want to implement this. What's good, the Nerk Nerds? How do you attach tmux? It's just tmux a. So tmux, the long version is just attach, but you can just like, I think it just resolves if you give it a character that only, I guess, expands out to one command, you can kind of just do the short version. So I just do tmux a, and then I'm detaching with leader d in case you didn't know. But yeah, we love tmux. Yeah, so we're going to implement this thing, and I have some ideas on how to do that. Yeah, trace scheduling, this little thing. Rearranging generated machine instructions, improve da-da-da. Yeah, so we got traces. This is something I need to think about. Hopefully there's I think this is the correct term that I'm looking for. Yeah, so this sort of thinking. Yeah, so this is kind of the inspiration for what I'm thinking about. What is happening here? Oh, actually no, this isn't quite it. I guess let's look at the Mushnik book because that mentioned it at least. Where is this? That's not it. Here it is. Switch, so that's why. Yeah, that makes sense. There's a lot of fun stuff to learn. Also, if you look at my dot files, there's a sessionizer script that I stole from Sylvan Franklin, who stole it straight from the Primogen. So if I just make if I'm just in here, I have a script, and this just like goes through a couple of directories I have, and then like it lets me fuzzy find through them. So like if I wanted to like open the panic test, I could just do like p just like already filters down to this, and then the test one is like there. So I can just like do lowercase t, and that fuzzy finds, and it's quite nice. That script is in my dot files, but I stole it from Sylvan Franklin, who stole it from the Primogen once again. So you could also look at their dot files as well if you wanted to steal that. I think that is the biggest workflow improvement that I've made to my tmux setup, at least. Why isn't it lazy loaded? it's not a NeoVim plugin. It is just like it is literally like a separate bash script. Where am I here? Let's look at this thing. Code scheduling, is this what we care about? Procedure? Not quite. 3 sessions? Oh, I'm not searching sessions. This just looks through directories, and if if a session in that directory doesn't exist, it just makes one. So that is kind of what I'm trying to do here. Blue screen because 3 Tmux sessions? Okay, yeah, fair enough, then that's tough. Okay, so there should be a thing here. Straightening? Huh? Wait, what? Oh, I guess this makes sense, sort of. Oh, I lied, this doesn't really make sense. Branch prediction, crazy stuff. What exactly are you making a compiler for? I guess so the goal of it is to be able to, so first of all, I want to be able to compile a subset of C down to x86-64, and then second, I want to be able to play with adding arbitrary passes and just doing various different code transformations. But at a more meta level, I guess the purpose of the project is just so I can learn more about modern compiler infrastructure, simply by just rebuilding as much of it as I can from scratch. I'm trying to figure out how to, or where the instruction selection stuff lives here in this book. Scheduling. That's useful, but not what I want yet. Trace scheduling. I think this is... Oh, this is not quite it. I guess... Can I look up fall through? Oh, fall through. This scheduling... Is this in trace scheduling? No, this is not quite, right? 17.1. It's in here. Okay, I'll need to read through this eventually once I have something that has been lowered. I can't do this yet, I think. Oh wait, no, this is what I care about, I think. Right? This is completely distinct. Top logical sort of the DAG that 1 produces the same results and 2 minimizes execution time of basic block. Pennant DAG basic block. Okay, this is not what I care about right now, I think. All this, oh god, why is it? Oh no. Okay, the pages are doing strange things. Don't worry about it. Trace scheduling. I think this is what we care about. No. Let's look at, maybe we could find fall. And the second one immediately follows the first to the first and the end with the unconditional branch the second. 18.4a? blocks beginning with L1 and L2 correspond to B1 and B2. Yeah, so that corresponds with that. First block ends with an unconditional branch to L2. Assume that block beginning with L2 has no other predecessors. Branch to the follow-through path. This is also not quite what I'm trying to look for, I think. Someone tree with AI in my discrete course today? Damn. That's crazy stuff. I mean, it's like, it's crazy in the sense that they didn't believe. I feel like it's just kind of common, for better, for worse. I guess for worse, but yeah, that's incredible. Okay, wait, where am I in this section 18? Wrap up? Unswitching. Wow, there's a lot of stuff here. None of this is what I care about, I think. Okay, let's look at the other books. What's his name again? Cooper? Yeah. So parsers. Okay, let's look through this. Linear. Do you know how to build a segment tree by using recursion? Man, I'm so washed, I don't remember what segment tree is. Oh. I don't remember off the top of my head, I can't lie. I'd have to like see something more concrete and I might get it, but there's a pretty good chance I also don't. I'm quite washed. Trace optimization? That's not what we want right now. Data flow analysis. That's not what we want. More optimization, instruction selection. Maybe that page will give me something interesting as well, just independently. I'm kind of curious what this says. Yeah, here. Where did I go? Patterns. Okay. Interesting. Okay, this is not what we care about though. Fragile lock, that we will figure out later. I swear no one talks about like instruction selection, or at least like Or at least like a lot of the other stuff in there. Like linearizing. I guess this is kind of an optimization for fall throughs anyway. So, I don't know. Okay, well, that's a little bit annoying. So it's not trace scheduling. We want actually when maybe this helps. Oh, actually, this seems pretty useful, actually. Which programming language do you think I should choose? I mean, I think the big thing is just like, if you have an internship, you should just like pick whatever they have. If not, then like you get a little bit more freedom. But usually, I think the programming, or like I guess the area that you're trying to break into will determine the languages you use a lot. Like I think if you're going into like generic web dev / SWE stuff, or like generically SWE, you'll have to, I think like Java's fine, C# maybe, or like Python. Everyone loves Python. But like if you're going into like system stuff, you'll definitely need to have a strong understanding of like low level, or like languages that I guess run closer to the metal. Okay, I think this page is the one that I've been looking for pretty much. So let me make this a readable size. Yeah, so we have statements. Yeah, of course. Let me know if you have any other questions. Okay, so Iris close to assembly, but the C jump. Yeah, so it goes to 2 different labels. Usually they just fall through to the next statement, and that could also be a jump, but yeah. The problem here is we have the, I guess jumps are expensive, so we want to use as few of them as possible. Yeah, so we want to maximize fall throughs is I guess what we call it, if you're not familiar with this sort of stuff. So there's 3 types of statements. So there's normal statements that are just like, we execute it and then we go to the next instruction. Next we have statements that do not fall through but just jump to somewhere. So yeah, these things. And then we have labels. So I guess like this is the whole build up to like the basic block thing. I guess let me pull up my little Paint.net Scribble box. Yeah, so if we have like a program, we can just like simplify it into straight line sequences and then I guess jumps between them. So like this is like the start. So this has like some instructions and then this is like go, or like this is conditional jump to like if like something is true, this goes to like T or it goes to F as an example. And then we have like 2 separate boxes here. We have like we have a T box and this has stuff, and we have like an F box. And each of these are basic blocks because the instructions inside of them, they always, for the most part, technically, I guess, you can think of them as executing sequentially, always. And then these would go to, I guess like cont as an example. And these go like this. Let's just draw arrows because we love arrows here. This does this, and then and then like a ret. This just like returns something. So yeah, these are basic blocks, and then, yeah. So if you remember what this said, there are ordinary statements, there are labels, and there are statements that transfer control. And the property of a basic block is it always has a label, it always has an instruction that, I guess, transfers control to another section, which we will call a terminator, and then we have normal instructions inside. So that is how we can understand the basic blocks, at least. Is there... Okay, yeah. This seems reasonable enough. Is DSA important in work? I think insofar, I guess like, I can't say that like it is the sole factor because there are a lot of things that go into just like software design. I think like there's a lot of other things like system design, just like understanding the language you're working with, understanding the problem. There's just like a lot of factors. With that being said, I don't think DSA is unimportant. I think it at least has some degree of importance because like if you don't know what a hash map is, you're very much in trouble, I guess. That is, I think, the way I go about reasoning about it, at least. Like, stacks are everywhere, queues are everywhere, heaps are some places, hash maps are everything, everywhere, everything. Yeah, there's just a lot of stuff. And you should at least be comfortable with / heard of everything. And I think the best way to use them is just like, or like get comfortable with them is just to like use them in projects. And then like making real choices about like which data structure to use. And I can pull up an example real quick actually in my code. Let's go to MIR. Yeah. So actually, let me just make a new window for this. Yeah. So if you look here, usually when you have like a list of sequential stuff, you'll probably use like a vector, which is I guess C++'s version of a dynamic array. Which first of all, if you don't know what a dynamic array is, I think that is definitely something very important to look up, or a dynamically sized array. But if you look inside of here, you'll notice like our program would have to be like, usually you'd see like a vector of like whatever the function type is, but I'm using a list. And this might seem like a strange choice at first because this is just a linked list, but this choice was a conscious one made, I guess, in light of, I guess, the trade-offs that you get between a linked list and a dynamically sized array. The problem with a dynamically sized array in this instance is that it's very slow to arbitrarily insert in the middle of it, and it's very slow to delete from the middle of it, because that would leave a hole, and then like you either leave a hole or you, I guess, have to like insert an element somewhere, and those are very bad time complexity in terms of the operations. So whereas a linked list, you can I guess you have like close to constant I guess like you have way better time complexity on inserts and deletes at arbitrary points rather than just the front and back. So that's why I use the list here, because we're gonna have a lot more of those than we, I guess, have just like straight like we still iterate through it a lot, but I think it matters a lot less the speed of that, because the operations we're gonna do when we're iterating through it, I guess, make the percentage of time that's spent just like iterating through it a lot smaller, I guess. So the trade-off, I think, in this instance is just very substantial, which is why I chose to use a list. Do you think C++ should be added to the Linux kernel, or should C++ not be in there? I think it's fair to not. I think it's fair to not allow C++. I think it's fair that, I guess, like, how do I describe it, I guess? it's really annoying to maintain code bases when they mix languages, I guess is the big thing. Because then you need to worry about like interlanguage interoperability, and then like there's just like a lot of mess. And I think it makes sense that at least for like a high performance kernel, I think C makes sense because C++ inherently will have some overhead. And if most of it's already in C, I think it's fair to at least try to use C as much as possible. And like, to be fair, like when people started trying to push to add C++ to it, I don't think C++ is a very mature language. The language as a whole is just kind of a mess, and I don't think it really plays well with like multi-language code bases. So I think it's a very fair choice. And like if someone were like, hey, you want to like write your register allocator in Rust, I would like think about it for a second, and I'd be like, I could, but like why, right? Like what advantage does it really give that is worth it? And like I think maintainability is a very big consideration that a lot of people don't think about, at least. Well, if you hate my life, people in age are so much more successful than me. Not really. I mean, it's all just a product of time at the end of the day. So I guess like first of all, like every emotion is temporary. So like if you feel like you're not doing so great, there will inevitably be low points. So if you, I guess like if you're feeling bad right now, there's always going to be some point where you feel like you're not doing great, and there are always going to be points where you are feeling great, and that is just like part of life, right? And the second thing, I guess speaking more to like the success part, I think that just comes straight from spending a lot of time working on things, and that all just comes down to your work ethic at the end of the day. And it's not a reason to give up, it's more of a reason to just like, I guess, spend more hours and just keep grinding. Like, part of the reason I started streaming was because I felt kind of like a fraud, and I think forcing myself to work on a project for an extended duration of time has helped me a lot with, I guess, like how I feel, and also like tangibly how much I know. So, it's like fine to like feel bad sometimes, but at the end of the day, that's what you should use to push yourself forward and to continue making progress towards improvement. How long did it take to get good at Vim? I started, I think, 2 summers ago, so like it's been a year and a third roughly, or 1.25 years. Close to 1.5 years actually, now that I think about it, but we're at like 1.25, I think, roughly. I think it took me 6 months to at least get comfortable working with it, but up until that point, it definitely felt a lot like I was relearning how to walk, I guess. So it takes a lot of time, but also incredible control flow graph here. Yeah, we have a great control flow graph. Can you like this page load? I don't know. Anyway, but yeah, I think I thought it was fun to switch at least. I also for a while used the VS Code Vim emulator plugin, which helped me get used to I can't speak. It helped me get acclimated to it, and then like when it was frustrating me, I could just like turn off the plugin. But you still have to like actively use Vim motions to get used to them. I wanted to use Vim in competitive, but it was too hard, so I chose dev. Yeah, fair enough. Like it doesn't really matter at the end of the day. As long as you can write code, that's a good time. Okay, I'm gonna get back to this whole pile here. I've chatted with y'all for a hot second. Yeah, so we have basic blocks. These have a label, a terminator, and then some sequence of instructions that are linear in execution. Yeah, so then using these, we can link them up and make a control flow graph. This is what this whole thing is, as an example. This website's really struggling, it appears. Maybe if I turn off Dark Reader? Nope. Okay, it's still completely borked. Okay. Okay. So So from there, so that's all stuff that like I've like roughly talked about before. The stuff here that I haven't thought about is traces. Yeah. So a trace is a path through the control flow graph, sequence of one or more basic blocks in which each block has a control flow edge and next in the sequence, and no block appears more than once. What the hell? Okay, let me just try to recreate their control flow graph real quick. I feel like that will help me follow this. So, yeah. Let's build this. L0. So this is C jump. So E and then L2 and L3. Okay, let's start with those two real quick. First time I came to the stream, I thought y'all use infrared light. I think I remember this. Yeah, that was good content. But yeah, IR is in fact intermediate representation. It would be really cool if we used light though. I remember like seeing a light representation of like a neural network, and someone was like, "Whoa, like we can use light," and then like someone was like, "Yeah, that's what we do with like cables." And I thought that was really funny. Okay, so we have L2 here. Maybe I should draw bigger. So we have L2 and L3. L3 is a call, F and X, that doesn't really matter, and then return. So that has no descendants. Now here, this is a move. Is Halloween today or tomorrow? It's tomorrow. Unless I can do... Sorry, I am like really struggling to draw for some reason. This is an X. Y plus Z. And then jump. We don't celebrate Halloween, we code? Yeah, I mean, I've got some ideas for something funny I could do on Halloween. It's nothing like particularly interesting, but I have some ideas. Okay, so this jumps to L1, and L1, L1's just a move. Base blocks are naturally init. Okay, these guys define basic block a little bit differently actually. Subsequence for all statements other than start and the end are ordinary. Maybe a label and maybe a jump return. I see. Okay, so if it doesn't end with a jump, I think it would just fall through, is what I'm understanding. Yeah, this website is really short. What if I turn off uBlock? Oh, it's block nothing. How to install NeoVim for C++? I'm not sure what you mean with that. If you're talking about like installing NeoVim in general, just use whatever package manager exists. If you're talking about like my C++ setup, I think there's like a couple things. I guess I can show that real quick. The big thing is just in LSP. I don't really have too much. I just use ClangD. Yeah, I use ClangD for my LSP, and then I have Clang format for my formatter. My bind for format is leader F. I use like default LSP binds pretty much. Yeah, I mean the C++ stuff in my config is like pretty minimal, I think. Most of the stuff is just like general NeoVim stuff that's useful. The DApp stuff is all the interesting stuff, which is like my debugger setup. Yeah, I'm not gonna spend too much time on this because None of this really is that special. I don't think I have any like crazy stuff in here. Yeah, like the Tmux navigation is like standard, tree sitter like everyone uses. I don't think any of my key maps are interesting. This one's really funny. Yeah, we have a light mode. We have a light mode toggle. But yeah. Yeah. As Niraj said, all of my dot files are in on my GitHub, which is in the description. So if you want to like take a look at that and like poke around, feel free to, I guess, do that. Okay, so it looks like this goes to L1, and then wait, what? Oh, I see. Okay, so this should go to that. But doesn't this just have an infinite loop, or am I tripping? Okay, I guess this just does have an infinite loop. That's really funny. Oh, you say Vim is better than VS Code? No. I think they serve different purposes, and I think for like VS Code's goals, I think it does a very good job. And I definitely used VS Code for a while. The only editor I will shit on is Emacs. Okay, so it looks like L1 goes to L2. We can do L1 here, I guess. This goes like this. L1. This is like some instruction, that doesn't matter here. Yeah, this is what the control flow graph looks like, which is a little bit strange, but I guess fair enough. Okay. So trace is just a simple path through the control flow graph. Sequence of one or more basic blocks in which each block has a control flow edge to the next one, and no block appears more than once. So these are all traces. So we start with 0. We start at 0. We go to 2. Yeah, let's just simplify this. Go to 2, and then we go to 1. That is a trace. Going from 1 to 2 is a trace, because we can't go back, because that will appear again. 0 to 3 is a trace, and then just 1 is also a trace. But 2, 1, 2 is not a trace, and then 3, 2 is not a trace, because the first one is not a trace because that duplicates the basic block, and then the second one's not a trace because there's no edge. So, okay, that makes sense. The ordering of basic blocks should be such that it creates large traces. For good performance, we should create traces containing frequently executed code. It cuts off. Great. Okay. Yeah, I don't know. I think the whole editor wars stuff is a little bit pointless. I only shit on Emacs because I think it's funny. But like realistically, as long as you can write code, I don't really think it matters that much. As long as you can write code and you can like be fast with it, I think that's fine. Like I still think like having multiple cursors in VS Code is like the coolest thing ever. Even though I could probably replicate a lot of the functionality with like just some simple Vim find and replace, I still think it's just really cool that it exists, and I used it for a while, so I kind of like understand at least. But again, as long as you like understand your tooling, I think that is more than sufficient. If you had to start all over again studying compilers, what would you do different? So I guess what I did, just as a reference point, I took a class, I did research, and now I'm kind of like starting from scratch again, almost just like re-understand the fundamentals. I think the big thing is I would have just paid more attention in class. When I was taking the class, I thought it would just be like a fun thing that I took, even though it was a really hard class. And I thought I was gonna like go into like machine learning or like web dev or something more mainstream. But as a result, I like only kind of paid attention in class. But I think if I like really knew I wanted to go into compilers and I took the class again, I would definitely just like give it double, triple, even quadruple the attention I did. I think that is the big thing, just like being intentional with my learning in the past. that is, yeah, I guess that's kind of that. Okay. So greedy reordering. I think this is the least awful way to... I guess this is kind of the algorithm that we want to try and do. It's also like not that complex as well, so that is what I want to do. So we have a list of basic blocks. So I guess like we can do like, I guess we have a set of like marked blocks, and then we have like traces. Am I a noob for using AI a lot? I understand the solution and code it myself, but sometimes I'm too lazy. I don't think that's bad. I think that's pretty fair. Like, I guess as long as you think of AI as like an intern, I think that's, I think that is the most healthy way to go about it. Like, if you want to like learn something, then like you still should do it yourself. But like, if there's something repetitive that you don't want to do, like I think it's fair to hand it off to the AI, and like, it will perform as well as an intern. Like, it'll either like do really well on something basic, or like, it's like the intern that like claims to know TypeScript, you know, like it's like written one program in TypeScript before. I think that is the amount of trust I would give it, at least. Traces, okay. So we have marked. Okay, I can't write an M. Okay, so marked section, and then we have the traces. So from here we can navigate through this. Yeah. So additionalize all is unmarked. So I guess I'm just gonna add to this. So repeat until all basic blocks have been marked. So we choose an unmarked block. Choose the block that has no unmarked predecessors. That might be a good one, I guess. Okay, so I guess we'll start with L0 here. So we choose an unmarked block, construct a maximal trace starting from that block by sequentially following edges to unmarked blocks, marking reached blocks along the way until no unmarked block can be added to the trace. This is hard because there's two ways to generate traces here. We can either do like, we can do 0, 2, then 1, and then we can, and then add 3, or we could do 0, 3, and then, I guess like 2, 1. Yeah, I think we should just like have some sort of traversal order in it. I made an AI for integrate sandbox development environment for a junior project at Cursor Clone. Think it's good to land a job with? I think that's a good start, at least. Yeah, I think there's a lot more than just like, it's not something I can really quantify, you know, like, it definitely will like play into it, but also like the rest of your profile also matters a lot, like previous experiences, other projects you have, I guess like, just like everything else that goes on your resume, right? So like, I think it's a good thing to have on there. I think that is like pretty solid in that regard, but I think it is one piece in a larger puzzle, at least. So to answer your question, I guess like, yes, I think it will help you land a job. I think it's worth having on your resume, but that is like a fifth of it, maybe. Okay. Okay, so by concatenating traces, we obtain an ordering. Some of the jump switching blocks need to be repaired to restore the desired program behavior. We don't like quote unquote need to, right? If we have explicit terminators, we don't technically need to have restore, or we don't need to like restore them, but this is all stuff we do in CodeGen, at least. If you remember from last stream, all the way down here, this little thing, this whole mess, this is like an example of that. And also, while I was thinking about this, it just occurred to me this invariant is actually wrong for various different reasons. I'll explain later. What is it about compilers that makes you passionate? I think the big thing for me is that uh, I guess it combines a lot of knowledge from a lot of different programming domains, and the largest, I guess like all of the domains it combines knowledge from are just like really interesting to me. Like you need a lot of knowledge about programming languages, obviously, because like you're working with programming languages. But you also need a lot of knowledge about like architecture and I guess hardware/systems for like the backend stuff and like generating assembly. And then like the whole thing is like a monster to maintain. So like you need a lot of like software engineering knowledge and like knowledge on like how to maintain large code bases. And then there's also like a lot of algorithms that are involved. So you need like a really strong foundation in algos as well. And I think like just the way these four overlap and make this unique intersection is just like really cool. How do compilers handle different styling techniques? It depends on the language mostly. Like for instance, in my parser, yeah. So I basically just ignore white space pretty much. That's how I handle it. And if there's like if the language doesn't care about white space, then like that will do that at least. And like when we encounter a white space character, I also group in like comments here. We just like skip until we hit something that isn't that. So the code isn't really modified. It's just like we read it in a way that doesn't care about it. What are some studying techniques you use? I kind of just go over the slides. I'm quite bad at like quote unquote studying, but like I find that the best way I learn is by doing. So just like project-based stuff is really helpful for me. Just like what I'm doing right now, I guess, on stream. Okay, so conditional jumps where the true case jumps to the next statement should have it inverted so the false is the fall through. That makes sense. I need to figure out this inversion thing as well. I think I will need to do that. Unconditional jumps to the next block should be deleted. Unconditional jump to the correct label should be added to the end of each basic block that doesn't transfer control to the next one. Yeah, this one we don't need to worry about because we have that explicit already. Delete the third argument of all conditional jumps and remove unused labels. That makes sense. What resources do you use? The big thing is just like, historically I've used my, the professor I took the class with slides because they're all pretty comprehensive. I guess there's like 3 books I've been looking at. The first one is this one. It's this Muchnick book. This focuses a lot on optimization. The second one is this Cooper book. I think this is a pretty holistic view of compiler design. It goes pretty much front to back on it. And then the third one is SSA-based compiler design edited by Rastella, and I can't pronounce his name. But this talks about like a very specific type of optimization and code structure. Okay, hate when you split screen while coding and all the code lines are too big and the resource is too small to read. Yeah, I mean, I guess that happens sometimes. Yeah, let me know if the code is too small and I can make it larger, I guess. Or just like yell at me in chat. Like, I need to get used to that. Beyond my projects, what else do I need to be able to land a screen roll at Google or something? It's a lot of technical knowledge. I think it's just like having a strong resume, being able to pass, I guess, like the code screenings and just like being a normal human being, I guess, to pass the behaviorals. Yeah. I think that's like the big pile at least. But I would also take my own advice here with a grain of salt because that's not really where I'm at. That's all just like stuff I've heard. So, stuff I've heard and stuff I go by. So, I would probably ask someone that is like actually more prevalent in tech right now. Get to work for one function, you get to go. That's true. That's true. It only needs to be generalizable to whatever I give it. Okay. Yeah. So this algorithm up here, this is kind of what I'm going to try to do, I think. Yeah, so we're gonna make traces. So yeah, I think we finally get to write code. 50 minutes into the stream, we are finally actually starting to write some code. So where all this lives is in this traversal file. And also I just realized I should probably rename this. I guess traverse traces, I think. I think that's what I will call this instead. It looks like I don't have something in the C++ file, so this is perfect. So yeah, we're gonna start this now. So we have traverse traces in the header. I also need to rename it in somewhere here. Backend. Yeah. So this should be traces. There we go. I don't think IQ formally matters in terms of like finding employment. I think it's more just like how well, like how your problem solving is. I guess like how well your attributes align to like the company, what the company looks for, I guess. And like this is all just like kind of company by company, unfortunately. I can't really give like a good heuristic, but like as long as like you're driven and like you can consider yourself quote unquote cracked, I think. There's not really like a solid like metric or anything. It's not like a very clear like red line or anything, but you kind of just have to like make sure you're on the more knowledgeable side rather than the other 50% of coders, I guess. Okay, traces. How do we do this? Okay. So yeah, this recursion thing is PMO, but all good. Let's deal with this. Yeah, so we have traversal order. I think we could kind of throw this on at the end and construct that. So we want a std vector of this we aren't going to be reordering, so std vector of mr basic block footer. Can I use the using in here actually? Or using trace equals std vector of mr basic block. Is this a thing? Oh. Wait. Okay, so this is just like in the scope. That's really funny. Okay, so I can just do that. Actually, I lied. I hate that. We're gonna keep this as a nested vector. Okay, so traces, and then std unordered set of our basic block footer visited. I guess the technical term here would be like marked, but this is fine. Okay, so then initialize all is unmarked, that's fine. Repeat until all basic blocks have been marked. So we choose an unmarked block. I guess we could just make a work list, huh? Yeah, we could do that, actually. Choose a hot block that is expected to be executed frequently. Okay, that's going to be difficult. Also, yeah, I'm sipping on Baja Blast because I have a sugar addiction. Anyway, okay, so I guess we could do a stack maybe, or a queue even. Queue? Does that make sense? Yeah, actually this makes sense. Let's do a vector of mr basic block putter. This is work list, I guess. Alright, this should be deck. Yeah, because that's what we will use for a queue. White space is a way to code and different letters separate in different ways. That sounds funny at first glance, and then you think about it, and then the problem is then I actually have to like write tests with that language, and I really don't want to do that. That seems not very fun. So I will abstain from that currently. But if you want to give that a shot, I think that could be a fun personal project. As an example. Okay. That's why I respect SLing does? Yeah, exactly. It's just like, programming languages are made for people, and some people are a little bit insane. Insane and cracked and very committed to what they do. Okay, so we want to, so we make these two, we make visited and work list. We wanna push back, F get entry block, and then arrow, and then, or actually, can we just initialize or list this? So we can just do this real quick. Okay, can we just do that, and then entry here. Yeah, okay. So that initializes these for us. Okay. So then, or actually this doesn't really work the way I want it to, I think. We can start with empty visited here. So then while work list is not empty, and we want to keep doing things, so cur is work list pop front. Oh, wait, no. Work list front. So then we can pop it, and then I also want a cur trace, I think, as well. Can we just do this? Can we... Is this a thing? What happens if I do this? Actually, that's very interesting. This just has an empty vector in it, right? I hope that's what this does. If it doesn't, then I will be very sad. But yeah, we can just like, yeah, I don't know. So we want her trace. So we want this. Choose an unmarked block. Choose the block that has no unmarked predecessors. What happens if we have a loop then? Yeah, that would cause a problem, huh? Hmm. Yeah, that doesn't help me actually. That is a little bit annoying. I guess we can do this, and then if visited contains cur, continue, I guess. Okay, so then auto cur trace equals back, or traces back. Type is this. Okay, this is a vector. Should this be a ref? Yeah, okay. We can do that then. Okay. So we can do that, and then what does this return? Oh, that just returns a ref, so does this need to be a ref? No, it's a value. No, this is fine. Is that this got this guy recommended? Well, welcome to the stream. Thanks for stopping by. Okay, so while cur, we want how do we want to visit this? So I guess we want to push back cur, and then visited, we want to push this back, and then we want to insert cur. Yeah, we can do this like this, I think. Yeah, we can do this. This is terrible. And then oh wait, this is not the right way to do this, I think. Day 79's dedication of this. Yeah, thank you. Are you still in college? Yes, I am. In my 4th year, I have the rest of this year and then 1 extra quarter to take. But then I am done with school. Okay, how do we do this? Just an unmarked block, construct a maximal trace. There's gotta be a better way to do this. Unmarked block, create a heuristic. I guess we could just make a priority queue of like predecessors, or sorted by predecessors rather. What are you working on right now? I'm making a compiler from C to x86. Right now I'm working on linearizing the optimizer language so that I can go through it and generate, I guess start generating assembly. But I am having a very hard time because this is quite difficult. Yeah, this algorithm's very minimal, at least, which is to be expected, but still. What made you interested in compilers? I guess like I took a class on compilers, I think like 2 years ago now, and I just thought it was really cool. So then I did like research, and then like I gave like a presentation, and it was like fun. So I've just been kind of writing that sense. There's a lot of like substantive reasons I like compilers, but that's relatively uninteresting, I guess. But that's what got me started, at least. Okay, can we make this algorithm suck less? So we can do this. If it's been visited, then continue. Yeah, this will, I guess, keep popping. That's fine. So we grab a trace. Yeah, so we can, while cur exists, yeah, so we can do that, and then for each successor in cur, get successors, get unique edges. This should be fine, right? Oh, this might not be deterministic. We could just do edges, actually. This is fine, I think. So for each successor, is this a ref? I think this should just be a putter. Yeah, okay. Okay, so if this is hard. So if it's been visited, then we can continue. We skip it, and then otherwise, man, what am I doing here? Okay. We should probably just take this out. Yeah, we should just do that. This should be a ref. So we can do this. This is useful because then we can just cur equals null putter. And then that handles the default case as well. But then this is like really annoying. And if cur, then this logic is terrible. I really don't like the way this is looking. So if cur, then we want to work list push back cur, or not cur, successor, else cur equals successor. Yeah, so then we always handle the successor if it's not visited. Yeah, and then this sets cur until the point where, yeah, until the point we visited every successor. And then we have a trace, so then yeah, we can actually yeah, we could just make a vector here. Yeah, this actually makes more sense. So we can do this. And that also gets rid of this like really stupid looking initializer list here. Yeah, so this way, yeah, that avoids that. So we can make cur trace. We can keep pushing back. Yeah. So we can get that. And then we can traces, we can push back, instead move, cur trace. Yeah, we can do that. And that's perfect, I think. Yeah, and then here we can, I guess, re-linearize this. Yeah, so then let's reach trace in traces. Actually, maybe we can traversal, order, append range? Or no, I don't like that. Or is there a... Let me just insert. Is this the thing? Okay, so this is the thing. So we can traversal, order, end. We can do insert as ON. I mean, yeah. Yeah, that is not ideal then. Is there a way we can just like join vectors? It looks like this is kind of the best way we can do it though, which really sucks. Yeah, I mean, this is fair. We can't really do much better than this, the more I think about it. Or at least like if we're... Is this actually? I think if we're inserting at the end, that's fine, right? Oh, that's not the what. Okay. That's also not what we're looking for. Insert within the vector, inserting at the star is pushback. Oh, I see. Yeah, that makes sense. Group of Chinese resources developed a shortest path algorithm with time complexity better than Dijkstra's. Yeah, I heard of this. I didn't look into it too much though. I think it's a very specific case if I remember correctly. Yeah, this all seems reasonable enough. Yeah, okay. I think this is all we need for this. I have no way of testing this right now, so that's a problem. I'm trying to think if there's a way I can like de-nest this a little bit, because I really don't like the way this looks though. Yeah, I think the little pile at the bottom is inevitable, but I think there's a better way to do this. Actually, we can just insert directly into traces. This, or not traces, just the traversal order. This is stupid. Yeah, we can do this. We can get rid of traces, we can get rid of this annoying thing. So we can do this. So we have traversal order. We don't need cur trace, I think, anymore. Because we can just... we can literally just traversal order. We can just push back onto that. And then we don't need this anymore. I think that works. Because we just, if we're gonna like flatten it anyway, we may as well just start with it flattened. Why are you not using namespace standard? It's just bad practice too, actually. I guess there's like a lot of reasons. I think the biggest one is like there might be like collisions within the namespace, and then the other big thing is like it makes all of your code also inside the standard namespace, which is just like really messy. And then it just like generally pollutes the namespace. And then like if you're trying to like use other projects, that also might cause problems with that. So the best practice is to kind of like either use your own namespace or use the anonymous namespace. And then just like use std whenever you need something from the standard library. I think I explained that poorly, so let me know if like there's anything. If you know what I'm talking about, let me know if there's anything I explained wrong. If anything doesn't make sense, let me know and I can like try to re-explain it. But yeah, the 5 characters of writing std all the time are much less a concern than the pollution of namespaces, at least. Okay. I really don't like the way this code looks though. This triple nesting is really insane. Okay, so we skip if it's visited. Is there a way we can like make this less awful? Maybe we could just like check visited before adding to anything. Okay, I think we could try to rewrite with that in mind. So let's try that maybe. I think we can assume that everything there is in the visited list, so we should also add entry to this. We could write it with that in mind. So we have cur, and then while this exists, we create a trace. We can do it like this, I guess. So we push that back. This should already be inserted, I believe. So then we get the successors and we set it to null pointer. I think that is the least awful way to do this, because then if it's all visited, then this is fine. Oh wait, no, this doesn't work. Okay, we do need to keep the thing like this then. But we could probably, yeah, because I'm thinking of a control flow graph that is like, let's make a new image. So if we have like, let's draw a box. This is like block A. This goes down to like B. And then these both point to C as an example. So in that example, we wouldn't be able, I guess like the longest trace so technically the longest trace we can make here is A, B, C in this, like this, and then like this. But if we do what I was trying to do there, so we create this trace and then we visit C, so this one we can't generate a trace from anymore. So then I guess that results in the same thing, but like I can think of a scenario where we make like a mess if this has like D as well. And that would be inefficient. So we can't really do it like this. We do just have to like kind of make a mess. How'd you learn NeoVim? I know Vim, but NeoVim has a lot of config. It's about the same. It's just, I'd argue it's easier because Vim has like this god-awful Vim script thing, whereas NeoVim is just Lua. So yeah. What is your rating Codeforces? I don't do Codeforces. I probably should, but yeah, I don't have a rating I can point to. Apologies. Are people hiring for compiler roles nowadays? I think there's still a decent amount, yeah. It's definitely harder to find than a lot of other stuff because the market's kind of, I guess like the whole hype around tech has always been around like web development and I guess like more recently like machine learning stuff and AI stuff. But I think compilers will become increasingly important. So I have a lot of reasons to believe that, and I think it's very possible for me to land a job. Which I also I might have news on soon, by the way. Yeah, stay tuned. I might have something start of next week to disclose. No hype or anything, but yeah, well, you'll see. You'll see. Actually, we should add in next. There's null putter. We can do this instead, I think. Yeah, this I think is a little bit less messy. This train car thing is not that bad, to be honest. So next, then we want to push that back. Implicit conversion, bruh. Next equals successor. What type is next? Wait, this is just a null pointer type. That's fucked up. Okay. Let's make this a basic block putter. There we go. That fixes everything. And then at the end, we want to set cur to next. Okay. Is there a better way to write this? Wishing you the best? Thank you. I don't like this. This looks messy. It just seems hard for me to follow, at least. Yeah, we can do this, I guess. Or maybe we could do this like a stack instead. Maybe we could use a stack instead. I'm not really sure how that affects the code gen. Yeah, I think this will be the best we can do, unfortunately, for now at least. If I think of a better way to write this algorithm, then like I will get to that at that point, but I think this is the best we can do for now, at least. Yeah, okay. Adding white space so it's like somewhat readable. I think that's a pretty good place for this. Let's commit this. Implement trace it, or implement trace traversal order, I think, correctly. Let's run tests real quick just to make sure nothing is broken. Hopefully this compiles. Okay. Okay. So, I guess the tests aren't really helpful because, like, we don't run any of our backend code yet. It's all the front end and the middle end right now, but at least it builds. That is at least a good sign. If there's a way I can make things testable, that'd be great. But yeah. Okay, follow through ordering, this we've handled now. Okay, so let's go back to where we were using this, which is in MR to LIR. So this we have now. So let's actually amend that real quick. Okay, so that's added there. I forgot to add that. Okay. This stuff all looks fine. I could probably skip this for now and it'd be fine. I'd need to... That is like a later priority. I think I want to at least get tree tiling first before that. Once we merge, we can do more complex tiles, but that's like, this is like the bare minimum. So this is calling convention stuff I need to think about. This I need to think about. Let's just look at all the to-dos that I have in here. So the first one, merge trees, I'll do later. Or I can't do right now. This one I can't do right now. This one I shouldn't do right now. This one I might do right now. This is all calling convention stuff I need to figure out. That one I can't do anything about. This is more calling convention stuff. This we should probably... Oh, I need to fix this actually. That's something I need to change because this invariant is wrong now. So we can get rid of that. Okay. So last time, this is in my Discord. Where did I put this? In my stream media, there we go. Yeah, okay. So this is the diagram I threw up last time. And last time I was like, yeah, this case is never gonna occur because like, we're just going to generate code in a way that doesn't happen. If you think about what our algorithm does now, this is very much a case that can happen. So, yeah, we're gonna need to figure out what to do about that one. So, yeah, let's reason about that. Yeah, so we're gonna need to make this a little bit more complex. Let's make a new image and steal that again. So in this case, I think we need to, let's just scribble over it again. We can't do this anymore. Yeah, so we can't do this anymore. Instead, I lied. Okay. So we want Cond branch opposite. Oh, this color is unreadable, sorry. Let's use a dark green. So we have cond branch opposite. You can just do like not true. Yeah, so you can do that. And then this goes to dot dot dot. And then this follows through to next. Is that. So this makes things a little bit more complex. So we need to check the two descendants, and then if one of them is like this is so confusing. Okay. Okay, so we could check false first, I think. So we can check the true branch. If that's next, then we need to do the invert. Then we can check false. And then if that is next branch, then we can just check the rest of this. And then we can check. Okay, yeah, okay. This makes sense. So we can go back to here. We just need to rewrite this a little bit. Okay, so true branch is next. So then we need to, this needs to be a little bit more complex. What's that terminal? It's west term. Okay, so we want okay, so in this case we want, let me just move, yeah, what's the best setup here? This is awful. Okay, so we want to generate the inverted instruction, I guess. Conjump for F successor, and then oh wait, no, we need to check if it's already existent. This is terrible. I hate this. Okay. Yeah, we can't assume, right? Or wait, no, we can assume. Yeah, because we know that is next block. We know the true condition is the next block. Yeah. Yeah, okay. So that actually is not bad. Yeah, and then we should fall through. Yeah, then we should fall through, and that's fine. And then we can return, I think. Or else block here, I think. So we can do this. Yeah. Yeah, okay. So then, yeah, this seems reasonable enough. So then we should probably reorder the thing to go the other way, right? Because we're already kind of trying to optimize around it. And I'd like to avoid the inverts as much as possible. Okay. So then you can go to where the hell I am. Okay, let's go to utils again, let's go to traversal. Let's change this thing actually. Is there a way we can just like traverse through this in reverse easily? I think we have a reverse range somewhere. Yeah, this thing. Which is awful, but... So we can change this. This will be cur, get successors, get edges. Oh, I need to include ranges. Whoops. Okay, what's wrong now? What is traversal order here? What type is this? It's a list. So this should work. Can I do successors, I think? Okay, so that works for some reason. I don't know why. But sure, okay. So we do that. Oh yeah, we should... reverse edges. Oh, wait, whoops. There we go. Ah, this makes me hate everything. But yeah, okay. So this should work now. Fix, outdated, invariant, and reverse. Successor, traversal, order. Okay. Yeah, I think that is probably a reasonable place to call the stream today. How long have you been streaming? Like 1.5 hours. I'm quite tired. Let's just push this real quick. Yeah, okay. I'm gonna call the stream here. Thank you all so much for showing up and watching, especially if you've been here for the entirety of the 1.5 hours and then some. That is a lot of time, and it really does mean a lot to me. If you haven't already, make sure you sub to the channel and like the stream. It helps get my content out to more people like you and helps out a lot with the algorithm. While you're done there, make sure you join the Discord. That's the best place to get pinged when I go live, and I guess chat with me and the broader community outside of stream hours. Everyone's really chill. Yeah, and then make sure you connect with me on LinkedIn and add me on GitHub to stay up to date with what I'm doing. Let's see if Aiden is live actually. He's been streaming recently. Yeah, Aiden is streaming. Y'all should check out his stream. He is doing a lot of interview prep right now, and he's really cool. He is the person that got me to start streaming, so if y'all have another spare like hour, you should check out his stream. Yeah. So if you're going there, I'll see you there, and if not, then have a wonderful rest of your day wherever you are. Take care, y'all, and take it easy.